So solving inequalities is really similar to solving equations. The only thing you have to be careful of is you need to make sure that your inequality sign is pointing in the right direction. So we're going to start with a really simple first example. We've got 3x minus 5 is less than or equal to 1. So same thing we would do when we solve equations. We want to get x on its own. So in order to do that, our first step should be to add 5 to both sides of the inequality. So we're adding 5 here and adding 5 here. That means minus 5 plus 5 is 0. So I'm left with 3x is less than or equal to 1 plus 5, which is 6. And then I'm going to divide both sides by 3. Okay, and 3 and 3 cancel out here, so I get x is less than or equal to 2. 6 divided by 3 is 2. So let's just check and see that this is correct. Now, it's a little bit different to an equation because it's not that x is equal to 2. X can be anything that is less than or equal to 2. So in the previous video, we looked at how to show that on a number line. So x can be a range of values, can be anything less than or equal to 2. So let's pick a value that's less than or equal to 2. Let's pick maybe x is equal to 1. Okay, so if x is equal to 1 and we put it into that inequality, we get 3 times 1 minus 5, and that needs to be less than or equal to 1. Otherwise, we've done something wrong. Okay, so 3 times 1 is 3, minus 5 is less than or equal to 1. 3 minus 5 is negative 2, and negative 2 is definitely less than or equal to 1. So that means we've done it correctly, okay, because our inequality is true. Now, when we did this, it was really simple. When you add something to both sides of an inequality, like we did in our first step here, the inequality sign doesn't change. And when we divide or multiply by a positive number, like we did in the second step, again, the direction of the inequality sign doesn't change. But when we have something like this next example, I've got negative 3x is less than 6. Now to solve, I'm going to have to divide both sides by negative 3. Okay, and what I get here is x is less than 6 divided by negative 3 is negative 2. Okay, so I think, all right, so let me do my check now. I need to pick a value where x is less than negative 2. So I can pick maybe x is negative 3. So negative 3, sorry. So negative 3 is less than negative 2, so I'm going to do that check on my original inequality. So when I substitute that back in, I get negative 3 times negative 3 needs to be less than 6. Negative 3 times negative 3 is 9. Well, I end up with this inequality. 9 is less than 6. But 9 is definitely greater than 6, so something's gone wrong here. And what happens is when you divide by a negative, you need to flip the inequality around. So we're going to start over. Okay, now again I'm going to divide by negative 3 on both sides. But what I've got to do now is I've got to flip my inequality around. So instead of that being x is less than negative 2, it's actually x is greater than negative 2. And now let's pick a value for x that is greater than negative 2. So we'll do a check. So x could be something greater than negative 2, so negative 1 maybe. So if I substitute x is negative 1 into my original inequality, I get negative 3 times negative 1 is 3, is less than 6, and now that's true. So I've done it correctly. So showing that on a number line, my solution was x is greater than negative 2, so x is greater than negative 2. And the thing that you need to remember here is that when you divide by a negative, you need to flip the inequality sign around. Okay, our last example here is going to be a sort of a double inequality, which looks a bit scary, but is not at all. You can actually break this into two separate inequalities if you like. So if you just take the left side here, you get this negative 4 is less than 3x plus 2. Okay, and now if you kind of take the right side, you get 3x plus 2 is less than 5. And we can solve each of these inequalities independently. Okay, so first thing, I'm going to do this one here. I'm going to subtract 2 from both sides. So on the left here, I get negative 4 minus 2 is negative 6. Is less than, that cancels out. So it's less than 3x. And then I'm going to divide both sides by 3. Negative 6 divided by 3 is negative 2. And those 3's cancel out. So I end up here with, and this looks a bit different to the way we're used to reading it, but x is greater than, because it's opening up there towards the x is greater than negative 2. So that's one part of my solution. X is greater than negative 2. Let's look at the other side now. Okay, so I've got 3x plus 2 is less than 5, so I'm going to subtract 2 from both sides, just like I did before. So 3x is less than 5 minus 2, which is 3. And to get x on its own, I need to divide by 3. Okay, so those cancel. And I get x is less than 3 divided by 3, which is 1. Okay, so I've got two inequalities here. I need to show that x is less than 1. So x is less than 1 would be kind of going this way. But x is also greater than 2, so greater than 2, so going this way. And that looks a little bit messy, so I'm going to redraw it down here. Basically, your x values need to be between 1 and negative 2, and not including either of those. So x could be negative 1 or 0. Those are the only two whole number values between negative 2 and 1.